Hello, I'm Hans Bezemer. I've been a programmer for 40 years, and I'm using Ford. The Ford is a deceivingly simple language that is notoriously hard to master, but it enables me to make more complex programs and faster than I ever could in C. In this series, I'm breaking down some of the most intriguing projects I took upon me. I once stumbled across a quote which was attributed to Michael Dell. Never try to be the smartest person in the room. And if you are, I suggest you invite smarter people, or find a different room. Now, I've rarely seen quotes of business moguls that were either honest or noteworthy, but this one struck me as particularly stupid. So, I wonder what would happen if you adopted this policy. It's easy enough to catch this one in pseudocode. If you are the smartest person in a certain room, you have two options. Remove a person from another room who is smarter than you and add them to your room, or remove yourself from that room and add yourself to another room. Let's define the data structures first. We need a person structure, and let's use his IQ to determine how smart he is. Furthermore, we need a reference to the room he resides in. Now we need a room structure, which needs a reference to identify it by. This reference is used by person. Now, there can only be 0 or more persons in that room, but we only need that room structure if it has some properties, apart from its reference. And although things like maximum capacity would most certainly make things more interesting, I like the idea of a meeting room filled up to the brim, with failing air conditioning if could be. So we don't really need this room structure. The first part of the program should be about setting things up, creating rooms, filling them with people, and assigning them an IQ. Now we can evaluate the whole setup. First we have to determine who is the smartest person in the room. Then we either reject this person from the room or we invite a smarter person. There are several ways to perform this evaluation, and each one has its own advantages and drawbacks. But I figured that it wouldn't make any significant difference in the end, so I went for the simplest one, sequential evaluation. The drawback of this method is that the smartest person could be kicked from the first room to the next room, and when that one is evaluated, he could be kicked out again. And in the end, he could end up in the very room he started from, nullifying the entire exercise. So let's take a look at the code. First, we define a structure for the person containing a property for his IQ and a reference to the room he resides in. Since resources are limited, we define a maximum number of persons. The number of moves, persons and rooms can be entered by the user. We clip those where appropriate. Now we can set the whole thing up. Persons are assigned to a random room and get an IQ between 100 and 149. So let's run it. We loop through all the rooms and determine the number of participants. If there are 0, we're done. If not, we list the number of people there and figure out who is the smartest of the bunch. He's got a 75% chance to be kicked out, 3 out of 4, and a 25% chance somebody smarter than him is invited. However, if he really is the smartest guy of the bunch, you won't find any. In that case, he's off the hook. And that's it. I've run this program countless times, with different parameters. Lots of rooms and very few people, or lots of people and just a handful of rooms. And this is what I found. If there are lots of meetings, but only very few people, virtually everyone is kicked around all the time. If there are few meetings with lots of people, the smartest guys have to move from room to room frequently. Shame I didn't design a large building with lots of floors and no elevators. So, there you have it. That's the merit of Michael Dell's motto. Smart guys never get the chance to even utter their ideas because they're too busy to get to another meeting. Either because they're invited or because they're kicked out. I'm Hans Bezemer and this was another episode of Back and Forth.